I ground off the lip that was interfering with getting this as close as I wanted to and centered over these holes, which are my trigger points. I'm hoping this can help with interference. I've also replaced the laptop with this stationary computer. That's cause this laptop isn't actually grounded to the mains. This is, and that should help minimize interference. The rest of the family has taken this whole week off for Easter vacation, and it would be bad if I didn't join them. Won't be doing much work out here this week. Sneak in a couple of hours here and there though, mostly for cleaning up the place and fixing some bits and pieces that's been on the back burner. You won't notice though, except for the video being a bit delayed. I was stupid and used stainless filler rod to weld the megaphone to my flange here, and both are mild steel, and it cracked along the edge of the weld, so I had to re-weld it with normal mild steel filler metal. It's all good now though. I've bought some exhaust tubing, and the plan is to weld in an extendable extension thing here, like a variable length pipe. I want to get a decent baseline with how it is first. Don't feel I got that in the last video because of the interference trouble. I'm hoping that's fixed, and I can't test that until Tuesday, maybe Monday. Today is Friday, and as it's Easter, Saturday, Sunday and Monday are kind of Sundays, at least as far as my neighbors are concerned. The holiday is over, the water is heating up. I'm ready to get a new baseline. Crossing fingers for no interference now. To get a proper baseline and then start playing with the megaphone. I've had a lot of time thinking about things, and an idea popped into my head just a few days ago. A theory, something I need to try and test. I'll show you later after this test run. My exhaust stream being heavily contaminated by fresh charge makes EGT numbers make no sense. I'm gonna repurpose the EGT probe as a charge temperature probe here. Reed valves look perfectly fine, which is good. I thought I'd solved all the problems. Turns out I just got more of them. There's something going on here. Look at the EGT gauge on the screen, and look what happens now when it's not connected to this frame. I can't see the screen, but I'm pretty sure there's a bunch of interference now and none now. Anytime the shield of the EGT wire touches metal, there's interference. I've turned off the eddy current power supply. It's not that. I'll try hooking up the laptop and see what happens. I moved it over here, but there's no difference. Motherfucker. I've been looking forward to this day all week. Just getting a baseline and then continue testing. Starting to think my dyno is cursed. Around 18 degrees, that's the temperature in here. Watch what happens when I touch the shield to the dyno frame. The thermocouple shield, which is connected at the sensor side. So now it gets connected to the engine. Now watch if I connect my laptop instead. I ground the shield. Nothing. Obviously there's some kind of a ground loop going on here, because the laptop is not grounded to anything. The tower is, and I thought that would help with interference. There's no connection between any of the wires and the shield. There has to be some kind of a capacitive coupling or something going on. This shield is in effect just an extension of the frame when this is grounded to the frame or the engine. Can't wrap my head around what's going on here. It would have made sense if the shield was connected at both ends. Then a ground loop would be inevitable. Though annoying, these problems with the sensor doesn't really matter because I can't use it regardless in the position I placed it, because it's not airtight. There's air leaking through here, through the tube. It's not sealed. I can't use this as a charge temperature sensor, intake temperature sensor. I'm gonna go get a pressure sensor and put in the same location as this was sitting tomorrow. My main problem is the interference on the RPM. Something is going on here and I can't wrap my head around it. That's what I'm gonna do now though. Sit here and try to wrap my head around it. Like this suddenly happened. There was probably interference before, but now it's become a problem and I can't figure out what happened. I've gone through everything and cables are shielded and the shields are connected at the right end, and I've even ran a fat ground wire from the frame and into the ground outside the garage. Seeing if that helped. Didn't. This video is sponsored by NordVPN. NordVPN creates an encrypted tunnel for your data to travel in. No one can spy on you and steal your data. With 5,000 servers around the world, you can appear to be from wherever you want. Comes in handy if you're traveling and you want to access stuff that's only available at home, or if you're at home and you want to access stuff that's not available at home. Streaming services, movies, games, etc. NordVPN is more than just a VPN though. Threat protection. Blocks trackers, blocks malicious and intrusive ads, blocks harmful websites and protects from malware. Threat protection will be a feature within the VPN application. No extra charge. It's free. NordVPN is the fastest VPN on the market. You won't notice any difference from when you were not running it. Try threat protection yourself, you won't regret it. It's available on Windows and you can download the Mac OS app from the NordVPN site. Head to nordvpn.com/twostrokestuffing and use the code Twostrokstuffing for an exclusive deal. It's risk-free thanks to their 30-day money-back guarantee. Thank you, NordVPN. A little turning therapy to get me out of the negative thinking hole. This is the start of a higher resolution trigger wheel for the retarder. I reverted back to having the sensor mounted to the crankshaft. I whipped up a quick bracket here. 1 signal per revolution with my 16 target wheel on the retarder and a 1 to 25-ish gear reduction. It turned out to something like 0.63, 0.64 triggers per revolution. The software can't do more than 1 decimal point. 0.64 turned out to be 0.6, and that's not really accurate. That's why I went and bought a pressure sensor to put in place of that temperature probe. Move the whole ignition system onto this chair away from sensor wires. Might reduce noise. Also relocated the power supply for the retarder and routed its wires away from everything else. High current. I made these quick and dirty guards for the load cell wiring. Could help with noise reduction. Certainly helps for abrasion resistance. Boost pressure sensor hooked up and seems to be working. I've got the head temperature sensor hooked up and it's working, and there's no interference, even though that's a thermocouple too. I think we're ready for testing. I've run out of time though. Tomorrow. I had the power supply connected to the wrong terminal. It's fixed now, and I've confirmed that it's working. Let's try again. Finally, some usable data. You can see we're hovering at around 20 horsepower with just the exhaust tub and ignition timing set at 20 degrees before top dead center. You can see boosts steadily decreasing throughout the range. And we've got head temperature logged. What's interesting is that it seems to gain power with temperature. The first run is lowest, the second one is higher, and the third one is the highest. Now let's test with the megaphone. Get ready for loud. I got 2 runs in, then the auto start feature started acting up. I'm not sure why. I'm making up a shielded cable for the connection between the retarder power supply and the Arduino box. That's the only cable left that's not shielded. I think those auto start problems were the retarder not getting a proper signal. It's just a PWM signal, 5 volts. Could easily pick up some interference when there's no shield there. Kind of stupid not running a shield. As last time, we lost power with the megaphone. We went from 20.5 to 17.7 horsepower peak. I've noticed my load cell readings drifting though. It's sitting at negative 1.5 now. Might be heat soaking into the load cell and it's expanding. Next time we'll start expanding the megaphone and see what happens. I'm gonna tell you about that idea theory thing I mentioned. Here's the inside of my cylinder. Exhaust ports and transfer ports. These transfer ports are blocked by reed valves. Here's the piston. After combustion, the piston uncovers the exhaust port and gas can escape through this area. When my transfer ports open, gas can't flow from the transfers into the cylinder until pressure in here is equalized with pressure in the intake plenum. Just like in a normal two-stroke, you want this area to be as large as possible to expel the gases as fast as we can. Now, as my transfers are separated from the rest of the intake system by reed valves, maybe we could do something like this. Ports in the piston creates a path from these ports to the exhaust port. Though kind of convoluted, it will increase my blowdown area because I can utilize the transfer port area above the piston also. Because I have these super high transfers, this wouldn't work in a normal two-stroke. One problem though, the piston is hollow. This would mean opening the combustion chamber to the crankcase, which I don't think would be ideal. I've actually got a couple of ideas and models ready, I'll show you. We could make kind of an extender piece for the piston. And that piece could ride in a block. That would completely close the underside of the piston off from the crankcase, or intake plenum in my case. That could work. Would add a lot of mass though. We could make an entirely new piston of this design. Don't know if you remember that Rieger deal. Didn't go too well. But this piston looks like those pistons. There's no exhaust side skirt on it though. I think I've got something that will work better though. So this is my first brute force design. Well, actually the first one didn't have dividers here between the exhaust and the transfer ports. Just a large cavity with the exhaust and the transfers connected. Did have these port dividers though for piston support. I went away from that because I was afraid fresh mixture would just short circuit around here and not scavenge the cylinder. And that's why this design came about. And then you've seen the evolution into what I'm running here now. I think I've got a solution to this problem though, and something that will have much more blowdown. It's fairly similar to what I'm running now. 2 rotary exhaust valves. This is pretty much the same as my first brute force idea. You have the transfers here and the exhaust ports here. They're all the same height, so they're connected. This relies on the reed valves taking the pressure when the piston uncovers the ports, which it seems like they're capable of doing. This in effect will mean I'll have an insane amount of blowdown area when these ports open. Pretty much the blowdown area of all the ports combined, even though flow from these ports won't be as good as flow into these ports, but there will be some. And I have twice the blowdown area already by running 2 exhaust ports. I think this is the next step in the brute force concept engine evolution chain. We'll do some more testing with this initial prototype first though. Stay tuned. Thanks for watching.